Hello friends, so far we have discussed recently regarding how to develop emission inventory for different source categories like residential, commercial, okay, for transportation sector, industrial areas, all those things. So, today we will discuss one case study so that you know how to apply those theoretical relationships which are used for developing of emission inventory, how these emission inventories are constructed and what are their applications or what kind of lessons we derive from those emission inventories. So, today's lecture will have this particular small introduction about the case study where we have taken it up, then what is the location of the study in different zones in Delhi, which is the focus area of this particular study, and the methodology which has been used for development of this case study of emission inventory. Then different sources which have been incorporated in this particular study like area sources, point sources or line sources related emissions. Then city level emission inventory for Delhi, because the case study is focused on certain number of zones, study zones are there, 10 study zones are there, we will see, but then it has been extrapolated to estimate the emissions from the entire Delhi city. So, that methodology also we will see into. Then we will see how the identification of hot spots have been done by this emission inventory, okay, where a lot of emissions are coming from. Then the total emissions from 10 study zones as well as total emissions from the city level of the Delhi, and then we will conclude. So, basically this study was conducted based on a common methodology which was delineated by Central Pollution Control Board, and NEERI in collaboration with the Indian Oil Corporation Limited and R&D Center Faridabad of that IOCL, and other oil companies like BPCL, HPCL, RIL, and they initiated this study for Delhi in year 2007 and it was published in 2010. Well, the major objectives of this study were like to measure the baseline air pollutants and air toxic levels in different parts of Delhi city, that is megacity Delhi you can say, including the hot spots where lot of emissions are coming from near like curve side of the roads, etc. Then to develop emission inventory for various air pollutants for projection analysis, so that we can project and analyze for the entire city Delhi, and then to conduct source apportionment studies for particulate matter, which is not part of today's case study. We have focused only in emission inventory development, right. Then to delineate an urban air quality management plan for exposure reduction, that is also not part of that, but we will touch like what is the lessons we can learn from these results which are of this particular emission inventory. So, this particular emission inventory has 10 zones and it has got two kind of distinct scales, like one for the 10 study zones of 2 by 2 kilometer, right, 2 kilometer by 2 kilometer around the air quality monitoring sites which are already functioning, and then the emission inventory which was developed for these 10 zones which were extrapolated, and total emissions for the whole city of Delhi has been estimated. So, two parts are there basically. Okay. Then what are different sources which have been incorporated in this emission inventory are like point sources, which are basically industrial sources like stack emissions, then area sources like domestic and commercial areas, etc. Then vehicular sources, that is line source. So, all point, line, area source have been considered, and there have been primary data collection also based on questionnaire survey and other specific surveys, plus secondary data have been taken from various kinds of published reports and other sources of data. Well, so these are the locations of these study zones like Anand Vihar, Ashram Chowk. So, in this particular map it is shown like small scale industry of Grand Trunk, Karnal Road, then this is Pitampura and Narayana, okay, then ISBT, Ring Road, Ashram Chowk, Dholakua, right. So, all these kind of these 10 locations of the 10 study zones are depicted in this particular map which you can see, and each zone has like 2 kilometer by 2 kilometer size, so that the detailed study can be carried out with limited resources, and then we can extrapolate, because these are the kind of representative zones you can say, and it has been prepared, this inventory has been prepared in terms of 5 major pollutants, which are like PM10, that is particulate matter of the size 10 micrometer or less, and then sulfur dioxide, oxides of nitrogen, NO2 etc., then carbon monoxide and hydrocarbons HC, right. So, these are the methodologies for emission inventory for every kind of category like area source, point source or line source. So, basically first of all data collection is there for any kind of activity. Basically you must remember, for emission inventory development from bottom to up approach, we go first of all for data collection. We collect the data which are needed for any kind of activity which is responsible for emissions of air pollutants. So, the activity data is important, whether area source or point source or line source. Activity data you have to collect, and then those total fuel burning or those kind of estimations are to be done. Then emission factors are there for each kind of activity. So, those are clubbed and then total emissions are estimated. That is the particular basic thing which every kind of emission inventory incorporates. So, data collection, then emission factors also, the specific emission factors means the localized or the activity based emission factors must be there. If there are no indigenous emission factors, then we have to rely upon some literature, some other like EPA or WHO reports also contain from different countries. So, whatever economies are similar to ours, okay, that we can borrow and we can use in the absence of the indigenous emission factors. Then the emission loads are estimated. So, like for example, for area source, first of all we must know the land use map, what kind of land use is there in that area, what are activities of domestic nature, commercial nature etc. Then hotels, restaurants or fuel use data, how much LPG or coal, kerosene are being burnt, all those things. Then emission factors are to be taken from Indian studies first of all, and otherwise like US EPA. In this particular study they have taken the emission factors from Indian studies, and wherever those emission factors were not available, so they have banked upon US EPA, United States Environmental Protection Agency's emission factors. So, that thing is common in all these. For line sources like vehicular categories, so first of all we need to collect data from like RTO office, okay, where we can get different categories of vehicles, numbers and age etc., right. So, all those data, then emission factors from our Pune based institute, which is automobile related institute, and then CPCB related emission factors are also there. For point source we need to identify how much industries are there or power plants are there. In this study zones which have been considered, there are no power plants, but beyond that power plants are there. So, they have also been incorporated. So, if we go by sources like different sources like area sources, so these like domestic cooking or heating, then burning of the waste derived waste derived fuels like those residues etc., then bakeries or hotels, restaurants etc., have been incorporated in point source. Large scale industries, medium scale industries or small scale industries, those related information we have, means in this study has been taken. Then in line source like 2-wheeler, 4-wheeler, 3-wheeler, and then which fuel they are being run by, like CNG or this gasoline, that is petrol or diesel, all those kind of related different categories have been taken up. Then, so data collection, as I said, that activity data have been collected with primary sources like survey based, and then the secondary sources from different kind of reports or publications from government as well as non-government organizations. So, this kind of data compilation and analysis was established, like matrix has been there, like air quality monitoring locations for Ashram Chowk, ISBT, Dhola Kuwa etc. Then how much population is there in that particular zone, how much slum population is there, because their burning of fuel is distinct than the other population. So, that has been segregated. Hotels, restaurants, then these dhabas or these sweet shops, bakeries, they also emit lot of emissions because of fuel burning in their activities. Open burning, then gen sets, because whenever electricity is not there, then generators are run. So, diesel is used and lot of emissions are there. Medical waste incinerators, okay, wherever. So, in these particular zones there were not neither medical waste incinerators or neither there were any crematorias. So, those kind of emissions were there, not there. Then locomotives were there, a few locations like Ashram Chowk and then Narayana, etc. So, those have been also considered. Well, so as I said, like hotels or open burning diesel locomotives which were plying to carry goods in between Ashram Chowk, Narayana, Anand Vihar locations, they have been also considered. Well, so emission factors, as I said that CPCB, Central Pollution Control Board, has recommended the emission factors for various activities. Okay. So, whatever emission factors were available for from CPCB, okay, then those have been taken. Otherwise, this EPA's AP 42 2000 emission factors compilation is there for different sources and activity. Those have been taken wherever indigenous data were not available for emission factors. Well, so area sources, if we consider first of all, then the estimation of population in each 2 kilometer by 2 kilometer study area was carried out. Then the slum population and the estimation of fuel consumption or comparison of the fuel consumption in summer. So, seasonal variation or winter seasons, that has been also taken up. Identification of the land use pattern, so that it can give different information, like ISER map was used in. Nowadays, sophisticated maps are there, but in 2007 they used the ISER map of the Delhi city for the land use patterns. Well, then the estimation of emission load in terms of 5 major pollutants like PM10, as I said earlier, or SO2, NOx, CO and HC. So, within that 2 kilometer by 2 kilometer estimations have been made, and this percent emission contribution for each source category has also been estimated when you have the total and from different sources. So, you can easily calculate how much percentage coming from different sources or how much percentage of a particular pollutant is coming from a particular source. So, those kind of things we can easily place. So, that has been given in this particular report. Well, so if we talk about the total emissions from area sources in those particular zones, so you can see like there are these emissions of CO, carbon monoxide. Okay, so from this small scale industrial area of Grand Trunk Road and the Narayana, they have been much more responsible for emissions of CO, carbon monoxide, and these hydrocarbons are also there, right. So, if we see the location wise, like PM10, the minimum emissions are from Dhola Kuan. Basically, Dhola Kuan and Prahladpur are responsible for minimum emissions of different pollutants. And pollutant wise, like PM10, maximum emission was from these small scale industries in Grand Trunk Karnal Road, and the NOx emissions were more in Anand Vihar, and the CO emissions were again from these small scale industries Grand Trunk Road. So, that way different locations have been identified where maximum emissions are there and where minimum emissions are there. Well, for point sources like industries, so the industrial point sources for that particular survey was conducted, and stacks were counted, how many chimneys are there, stacks are there which are emitting those air pollutants. Well, boilers, furnaces related data were collected, and then total emission loads were estimated by those using those formula which are used for stack emissions. Well, then the data collection has been done from National Council of Applied Economic Research related reports 2002. There are like in 2002 this was 17,112 polluting industries. So, that way those data have been there, and this 2,266 units are polluting in nature from DPCC data that was taken out of which. Okay. So, segregation has been there, large scale, medium scale, small scale. Okay. Small scale are like 2 to 5 to industries are there, and then in large scale industries power plants were considered. Basically, there are like 5 plants, but they were not in those study zones, and these 3 are located in IP state, and then the 2 are near Pragati Maidan and Badarpur area. So, those have also been considered. Okay. Then medium scale industries concentrated on Lawrence Road industrial area. So, those have been also considered in this study. Well, when we talk about these small scale industries, and if we see where they are located, so Mayapuri, Anand Vihar, Narayana, and this small scale industries Grand Trunk, Karnal Road is there. So engineering studies, like if we zone wise, if we see which kind of industries are there which are responsible for various kind of emissions. So the engineering, chemical, metallurgical, okay, pharmaceutical, so those kind of industries are there, and then other industries, other kind of which are not in this particular category. Well, when we talk about like engineering industries are their emissions from different small scale industries. So the engineering industries, metallurgical industries are responsible for maximum emissions, you can see, and NOx emissions are coming lot of from all these kind of industries. So you can see the dominating emissions are NOx from these particular industries in a very large quantity. Well, if you see these from industrial sources, again pollutants like PM10 or sulfur dioxide, NOx, etc. So again NOx is dominating, and then CO is also there. So you can see the difference between different kind of areas, like this small scale industrial area of Grand Trunk, Karnal Road is the major contributor if we compare with other industrial areas. Mayapuri is the least polluting area in that sense. Well, now if we talk about like line source emissions, that is vehicular emissions. So we have considered like area source, point source, and now line source. So line source basically vehicular emissions you can think of. So these are responsible for a large amount of like CO, NOx, etc. And they have vehicular pollution has increased from 64% to 72% in the last decade. So lot of growth has been there. Well, so for this calculating estimation or estimating the emissions from vehicular category, so primary data of the traffic counts have been collected from RT office. Then different kind of categories like how many vehicles are there of 4-wheeler category, 2-wheeler, within 2-wheeler 2-stroke engine, 4-stroke engine. So those kind of categorization have been there, and those values have been taken into. Then estimation of these pollutants like particulate matter, CuHC, SO2, NOx have been there in that area. So how many vehicles are there? It is easy to take those data from this RT office and then calculate the emissions with the help of emission factors and the total vehicle this how many kilometers one vehicle travels. So that average value can be taken and multiplication can be done very easily. Okay. So the survey was conducted to have the primary data on different locations. Okay. So that way some people those who can do a good survey were hired, and they counted vehicles at particular locations of different categories of the vehicles, right. Then the road category wise traffic count you can see here, like at the RTL roads you can see most of the trucks are plying on the RTL or the roads, and the main roads are responsible for like 4-wheelers and these light commercial vehicles also in large number, and 3-wheelers basically go on the main roads mainly. Then feeder roads are there, so they are having like 45.7 percent if we count these 4-wheelers, then they are mostly on these feeder roads are plying. So those kind of categorization have been done. Okay. Now if you see this vehicle kilometer travelled VKT in each study zone, so for each category of vehicle this VKT has been taken into account from different reports, and those counting of vehicles plus these VKTs, and then emission factors have been used for emission estimations. So you can see these fleet age composition have been considered, 2-stroke, 4-stroke, 2-wheeler ratio have been considered, then emission factors from ARI has been used, and the emissions have been estimated. So you can see the how many categories are there of the vehicles plus which pollutants like PM10, CO, hydrocarbon, NOx. So total emissions of the vehicles in 10 study zones, if you see, the maximum emissions are of the CO, carbon monoxide, and then second is the NOx, and then hydrocarbons. Naturally from vehicular categories these kind of emissions are more basically. Okay. When we see vehicle category wise emissions, then particulate matters are mainly emitted from the trucks, as you can see around 48%, right. 38% or so the CO emissions are coming basically from 4-wheelers. Okay. So, if we want to curb the or we want to reduce the emissions of CO, then we need to focus on 4-wheelers first, right. If we talk about hydrocarbons, then they are mostly from 2-wheelers. So, if you want to control hydrocarbons, then better to control the 2-wheeler related technology, and NOx emissions are basically coming from like heavy duty vehicles, trucks, etc. So, those are the major sources of different kind of pollutants. Well, then when we talk about this resuspended dust, so it has been estimated that near ISBT, because lot of vehicles are there on their this bus depot, main bus depot is there, and then bus terminal, and then this small scale industry, this Grand Trunk Road also has lot of contribution of the road dust because of resuspension. So, these are basically two locations where lot of dust suspension has been there. Well, the pollutant wise identified highest and lowest polluting zones if we want to consider. So, the particulate matter highest is from ISBT area, okay, and this and then high is from this small scale industry Grand Trunk Karnal Road, and lowest is in Prahladpur. Okay. Similarly, for different like hydrocarbons made this highest in Ashram Chowk, lowest in Prahladpur. So, Prahladpur you can see mostly that is the lowest emitting sector or location or the zone for different kind of pollutants. Well, when we talk about city level, because these were the zone, whatever 10 zones were selected by these researchers, those were the emission inventory developed. So, city level emission inventory was developed based on those emission inventories of 10 zones basically. So, extrapolation or projection you can say have been done based on the emission estimations which have been done in those particular zones. So, there have been estimations or projections based on certain things like population data, how much fuel consumption is there. So, census data has been taken, and then fuel consumption has been taken from different reports. So, you can see this population in lakhs, and the slum population as well as urban population, rural population, those kind of population data have been taken. So, the emission estimates from area sources were taken from projections of those estimated values. So, it was seen that domestic slums were responsible for the maximum emissions of carbon monoxide and hydrocarbons, and residential area was also the responsible. So, these two major areas were there for emissions, large amount of the emissions, and basically if you see these NOx emissions and CO emissions and the hydrocarbon emissions, they are the dominating ones even in area sources. So, that is the situation to worrisome, because these are the precursors of ozone. So, in case ozone production starts to take place in summer and in photo wherever solar insolation is good, then this is another big problem which we can foresee, and we have to think seriously about reducing these emissions. Well, when we talk about category wise distribution of emissions from area sources, so you can see like 44% is coming this PM10. So, major 44% is coming from these construction activities and domestic slums. Okay. SO2 emissions in large quantities coming from hotels, restaurants, because they use those kind of fuels, coals, etc. So, again domestic slums are also there in this particular contribution for SO2. So, we have to see pollutant wise, like NOx emissions mostly coming from generator sets or domestic emissions, CO emissions from domestic slums, hydrocarbons again from domestic slums and domestic emissions. So, you can see these area sources are also responsible, because we have seen that these CO, hydrocarbon, etc., NOx, they come in large quantity in from vehicle category, which we will see again, but area sources are also giving this large quantity, and that is the worrisome issue. Then this grid wise emission inventory has been developed, so that we can know which particular areas are there where lot of emissions are coming from. So, you can see this red color area, they are the most responsible for large amount of the emissions, so that we can first go and see what we can do to reduce in particular those kind of hot spots where lot of emissions are coming from. When we talk about like this industrial emissions, so as I said earlier that this NERI team visited all industrial areas and counted how many stacks are there for different kind of emissions, right. So, they have taken also into account like what kind of technologies they are using, like if ESPs are being used, then particulate matter emissions are very low, because if that is effective for reducing the emissions. But then the SO2 NOx emissions are also coming. So, you can see emissions from thermal power plants, and a lot of emissions are there of again CO, and then like from Pragati thermal, this CO emission and this hydrocarbon emissions are quite high. Well, when we talk about again this gas turbine power station, so same story is there, but if you talk about NOx emissions, then this Indraprastha and Rajghat and Badarpur, they are quite significant amount of NOx emissions are also there. So, we can see percentage emissions from these thermal power plants, and Badarpur thermal power plant is responsible for quite high amount of PM10 and SO2, but this Pragati thermal is responsible for highest amount of CO and hydrocarbon. So, that way we can see which power plant is emitting which kind of pollutant in a large quantity. Well, when we see these emission estimates from small scale and medium scale industries. So, basically when we talk about medium scale industries, again the dominating emissions are of NOx emissions. So, as I said that this in Delhi, basically these NOx, CO, hydrocarbons, etc., they are the things to be concentrate upon based upon this particular study. It is old study, and maybe appropriate policy measures were implemented based on this particular study. Here also, like large scale industries are responsible for like PM10, NOx, etc., and CO are from small industry, small scale industries. So, small scale industries are responsible for CO as well as large scale industries. So, fair share is there, you can say. Otherwise, for PM10, SO2 and NOx, dominating source are the large scale industries. So, again you can see what is the contribution of percentage contribution of different industries for different pollutants. So, large scale industries are responsible for very high amount of all kind of emissions, of course, but like if you talk about CO, then small scale industries are also very much responsible. Well, again, so grid wise emission inventory was development distribution of these emissions were done grid wise, so that we can know the hot spots. So, you can see here this ISBT and this Ashram Chowk have been identified as large amount of these emissions. Well, so methodology for estimating vehicular emissions. Now, we come to, so methodology, as I said, this is based on VKT, vehicle kilometer travelled, and the emission factors. So, in those 2 by kilometer, 2 by 2 kilometer by 2 kilometer, they were estimated, and those were projected for Delhi basically. So, the total length of roads have been identified for different kind of roads like ring roads, and then feeder roads, or those kind of these arterial roads, all these kind of roads. So, how many vehicles are plying on those particular roads. So, those data have been used for extrapolation of those estimations which were taken from the specific zones. And we can see like a lot of emissions again of this NOx emission and the hydrocarbons and CO. So, they are also it is very intuitive that vehicular emissions mostly emit those kind of emissions, NOx emissions and CO emissions. And you can see again distribution. So, to identify the hot spots, you can see like these kind of grids are there which are responsible for like grid M8, okay, this 8 and this M. So, this M8 grid is very much responsible for high value of particulate matter, if we see around 362 kg per day, right. So, that particular methodology was used for identification of hot spots, and those hot spots are like M8, M5. So, these are the names of the grids, and these grids include those particular prominent areas like M8 India Gate, Rajpath, Vigyan Bhavan, Udyog Bhavan. Okay. So, lot of emissions from vehicle categories may be there. Then ISBT, Kashmiri Gate, and you can see all these kind of names which are in particular grids are there. Well, so to identify the hot spots, then grid number 10, Toll Plaza, Chila, this Alka Cinema, they have been identified. So, you can see the grid and you can see which places are there which need to take the attention of the policy makers. Well, when we talk about the total emissions in 10 study zones, so there are variations are there, like you can see this as I said small scale industrial Grand Trunk Road and the Narayana, they are dominating for particulate matter and NOx emissions, you can see. So, that way different kind of zones have different kind of information, but when we talk about total source emissions these study zones, then line source emissions are dominating basically for these NOx as well as carbon monoxide, that is the vehicular category basically. Point source is dominating NOx for NOx, okay, in point source, and in area source CO is more. So, that way you can see which pollutant is coming more from which particular source category. Well, when we talk about at the city level, so the NOx emissions are the highest basically, and they are coming from industrial as well as vehicular emissions, okay, these NOx. Second is CO, which is coming majorly from vehicular, and then the second is from area sources. So, and SO2 is basically coming from industrial sources. So, these kind of information is there, and as you can see this lot of emissions of NOx is there, and I always repeat it that because of their NOx and CO, hydrocarbons etc., precursors of ozone. So, we should be quite sensitive about these kind of pollutants, how to reduce them, because they may create another problem in future if we do not give due attention. Well, source wise emissions at the city level also you can see, like these CO emissions, NOx emissions, hydrocarbon emissions, they are dominating, okay. PM emissions like 52.5 from the road dust basically. So, that is the major source, but for CO emission the vehicle categories are the most, second is area source. For this hydrocarbons again vehicle and area source are responsible, and for NOx emissions again industries and vehicle categories, industries are more responsible. So, that way you can see like SO2 only industries are there to control. So, according to their amount, we can look into that which kind of source we need to first focus upon to apply certain policy interventions or technological interventions, so that those emissions can be reduced and air quality can be improved. So, this is basically case study how these emission inventories are developed and how they are used for inferring information or insights, as we have seen which kind of pollutants are more, and how to focus upon some policy decisions or technological interventions specifically for those pollutants. Otherwise, they will create some other problems, whether health related or ecological related. So, we can say that in this study we have seen this emission inventory which was developed focused on certain zones, and then extrapolation has been done for city level, and then hot spots were also identified, okay, and it is also identified that specific pollutants like NOx are being emitted in large quantity from different sources, and we can categorize or target those sources to reduce the emissions of NOx or CO and hydrocarbons, so that we do not fall into that kind of problem of ozone production, because ozone is a very hazardous pollutant in the troposphere, although it is good in the stratosphere as you know. So, those kind of inferences or insights can be developed by these kind of inventories. So, I hope you like this particular case study, and these are the references where we have taken information for this particular case study, and you can go through this information in your free time. So, this is all for today. Thank you very much for your kind attention. See you in the next lecture. Thanks again.